Hey guys, welcome back to your second lesson of this unit. So we're going to start off with this warm-up, and again, know that you can always print out the PowerPoints if you would like to use them. Let's see if I can get the pen to work though. Come on, pen. Oh, there we go. Okay, so we're going to use some of the stuff that we did in the last lesson and some of the stuff that we've learned in general. So we want to figure out this value of y. So that's this length. Right? So here we know these two sides are equal. So this is a 45, 45, 90 right triangle. And what did we learn in the last lesson about a 45, 45, 90? Right? So you have your two sides. You have x, x, and then your hypotenuse is x root 2. Right? So I know that this side is 8 root 2. And then to figure out the hypotenuse, that third side, I'm going to have to do 8 root 2 times root 2. Well, what is root 2 times root 2? Well, that undoes itself, right? That's like the square root of 4, which is just 2. So that length is just 16. So that means that this entire length is 16. And that means this length is 16. This is an isosceles. I'm sorry. It is isosceles. This is an equilateral triangle. So these two angles are 30. Oh, well, what do we know about a 30, 60, 90? Right, so we know that we have the shortest side. The hypotenuse is 2s, and then that side in the middle, maybe I should have put it right there, would be s root 3. So let's see, I'm trying to find, the altitude, right? That was a word that we talked about in the last lesson, altitude. The height, that perpendicular. So here, this is going to be 8. And then this side right here is going to be that shortest side times root 3. So there we've got it. Y equals 8 root 3. So some application of special right triangles there. And then for this next one, we want to write down the equation of the circle in standard form, right? So that takes us back to last unit where we had x minus h squared plus y minus k squared equals the radius squared. So h and k are the center. In this case, that center is 0, 0. And r is your radius, and in this case, your radius, is 1, right? And we could look that in any direction. So we get x squared plus y squared equals 1. We're going to be continuing to work with this specific circle throughout this lesson today. So the objective of this lesson is to use what we know about circles, darn. Using what we know about circles, you're going to be able to change between radian measure of an arc length. So maybe you know what some of that stuff is. This might take you back to the end of geometry last year. So radian measure of an arc length to degree measure of an angle and vice versa, right? This is what we're more familiar with at this point. Do you remember in the last lesson I told you to go to mode in your calculator and make sure that you are in degrees? However, I told you that your calculator defaults. We're not going to be using our calculators too much, but this is still good to think about. To radians. Maybe you even remember some things about an angle measure in a circle and the arc it intercepts in that relationship. That one happened about a year ago for us. We did that in geometry around this time. Right, so we're going to be doing some conversions. So really a lot of, and the same thing with the last lesson as well, is really just kind of building the foundations for what we're going to be doing in trigonometry and just making sure that we have these strong foundations for it. So what is the distance around the entire circle, which we also know, and we often call the circumference? Well, maybe you remember that circumference is pi times diameter, or sometimes it was 2 pi r, right? Well, this is the same circle we had in that warm-up. So the radius is 1. right? That length is 1. So the circumference is going to be 2 pi units. So if we started here, we went the whole way around the circle, that's 2 pi units. How can we find the distance around a portion of the circle? So maybe we don't want to go the whole way around. We only want to go a piece of it, right? You might have known that as arc length last year. So what about 30 degrees? A 30-degree arc, right? So if this central angle right here was 30 degrees, so this arc is 30 degrees, how would you figure out that distance, right? We know the whole thing, like what portion of 2 pi is that, right? Well, 30 degrees is how many degrees out of 360, right? So what fraction of the circle is that, right? Maybe that's 1/12. So we want to figure out what 1/12 of 2 pi is. Oh, that's just going to be pi over 6. What if I asked you for 45 degrees, right? Like this quarter slice. I guess it's not really a quarter, it's like an eighth, right? That's an eighth of the circle, of the entire circle, so an eighth of 2 pi. Well, that's going to be pi over 4. What about 90, right? That's 1/4 of the circle. So that's 1/4 of 2 pi, which is going to be pi over 2. How about if we really went for it and I asked you for 225? Oh, that's not connected. I feel like that I didn't get very good at drawing over here. So that's like more than half the circle. It's like a half and then an extra quarter. It's like half and then half of a quarter. That wasn't a very good description, right? So that's like 5/4 of a circle. 5/4 of 2 pi, right? This is like 4/4 plus 5/4. So what's that going to be? That'll be 5 pi. Nope. No, that's not right. It's not 5/4. Sorry, this is 4/8. This is 5/8. Wow. I don't know what just happened. I can't count, right? I'm saying a quarter, but this whole thing is a quarter. Like 90 is a quarter. So this is going to be 5/8, which would give you 10/8, which would give you 5/4, 5 pi over 4. So what's happening here? What just happened? We actually found the equivalent radian measure of each one of those degrees. That's really what we did. So 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians, right? We did that 225, that one that I just screwed up at the end, was 5 pi over 4 radians. So we're finding the radian measure. When I'm asking you to tell me how long that part is, it's really just the radian measure. What exactly is a radian? So I want to show you this applet. So I'm going to go with, so here my radius, this is just kind of neat to play around with. Here my radius is 2. I'm going to change it. I want my radius to be 1, so we're dealing with the unit circle that we were just dealing with, okay? So, and then I can kind of, no, I can't. I can slide this slider to look at like different angles, and the same thing, like look at the length. So if I get to 90 degrees, this length is about 1.57, right? When we figured that out in on the last page, we said it was pi over 4. Did we? No, we said it was pi over 2, which is about 1.57, right? If we look at this, 1.57 radians, right? That's the radian measure. I could keep going. 180 degrees is going to be what? Not too far. Oh my gosh, pi radians. 360 degrees. Let's go the whole way around. Can I get there? Need to make this bigger, maybe? Is 6.28 radians. Oh, that's 2 pi. right? So the radian measure, this is going to change a little bit, right? Because as I make it bigger, right, as I change that radius, obviously the circumference and the length is going to change. However, this radian measure doesn't change. When I go back, when I go back to, let's say 90 degrees, if I can get there. If I go back to 90 degrees, this length is now not equivalent to its radian, right? It's based off, because I'm doing 2 pi times the radius, so it's the unit circle that does it for me. The unit circle makes it so that that length, and we were working with the unit circle on that page. So 1 radian is actually 1 radius length around the circle. So 2 pi radius lengths fit around a circle. Right? 2 pi radius length. That's why it's 2 pi r. Right? So whatever that radius length is, if I multiply it by 2 pi, that's the circumference. I'm going to show you one more applet. So I thought this was kind of nice to see too, and I can show that. So here I have a radius of 2. Whoa. No, I don't want to look anything up. It's a little slow. We'll give it a moment. No. I want to drag it. So if I drag this around, you can see right up here what's happening to the radian. So as I go there, oh, there's 1 radian. Oh, that's 2 radians. And look, we can tell the length of it. Oh, that's the radius. Oh, that's 3 radians, right? So that's like 3.14. That's pi radians. I'm a little bit more than 3 of the radii that are fitting around there. Oh, there too. I keep going. How many are going to fit? I've got 1, 2, 3, 4, 5, 6, and a little bit more. Right? So it's just a nice visual to be like, 1 radius is 1 radian. However long that radius is. That's the circumference. So 2 pi radians is 360 degrees. And there's some that we're going to work with that are special angles. Oh, wow, that ties in with special right triangles, doesn't it? It's going to. That we will work with a lot more. So I think it's the fraction of the circle is what really we're working with the radian. So think fraction of even more semicircle, right? If you don't want to think about it in terms of 2 pi, think about it in terms of 1 pi. So we're going to think about these without thinking about picking up our calculator. So 225 degrees. Let's think about where that falls if we were to graph it. Well, I'm going to start here. If I go around the circle, I'm going to end up like down here, right, in the circle. So I'm going to end up in, that's quadrant 3. Ooh, that's interesting. So this right here, oh, I think we did this one actually. So it's how much of a semicircle. Well, the semicircle has 4 corners. It's 1 quarter more. So it's 5/4 of a semicircle. So the radian measure is actually 5 pi over 4. Right? So think about that. What about 210? Where's that going to end up? Well, I start here, I go around. It's going to end up like right here. That's 30 degrees more. So, right, because this is 180. That's halfway around. Here's the semicircle we're thinking about. Right, so it's all of this and then a little bit more. So it's going to be more than 1. It's going to be more than pi, but it's going to be, we want to go 30 degrees more. So let's think about that piece of it. Well, what fraction of a semicircle is this? Think about that for a second. And 210 is how much of 180? It's going to be more than 1. 7/6 of a semicircle, right? Which means that we have 7 pi over 6. What about 270? Think about your circle. Ooh, that ends up, that's right down here, right? That's on the negative y-axis. So that's going to be 1/2, 2/2, 3/2, right? I'm saying half because I'm thinking fraction of a semicircle, right? So this right here is going to be, this is 3/2 of a semicircle. So it's going to be 3 pi over 2. Let's go the other way. We want to kind of transition our thinking into radians. So this is 5/6, that's hard to say, of a semicircle. So if we were going to graph this, let's see, we start here, 5/6, it's not a full 6/6, it's not a full semicircle, it's like a little bit less, it's actually in quadrant 2, right? So I want you to think about this. A 6 of a semicircle, well, that's 30 degrees, right? 30 degrees is going to be a 6 of a semicircle, and then we want 5 of those. So we end up with this is just 150 degrees. Radians help us to think more in the fractions of the circle, right? So for something like this, 7 pi over 3. Well, 6 pi over 3 is 2 pi, and that's a whole circle, right? That was the entire way around. So if you think about it, I'm going to be going the whole way around and then a third more. A third of a semicircle more. So I get that whole thing plus 1/3 more. So it's going to be 360 plus 60 more. Right? This is going to end up being, what is that? 420 degrees. Right? This is 7/3 of a semicircle. What about this one? This is 7/4 of a semicircle. Oh, that is not working so well. Semicircle. So if we go here, we have the circle. This is 1/4 of a semicircle. This is 2/4. This is 3/4. 4/4. 5/4. 6/4. 7/4. Right? So that's in quadrant 4. We're going this whole way around. Well, 7/4. Well, 1/4 is 45 degrees. Right? A quarter. So you're going 7 of those, right? So you're thinking it's got to be 7 times 45. So how many degrees is that? 315 degrees. All of these angles that I'm talking about here are what we call special angles. If you notice, they're all increments of 30, of 60, and of 90, and of 45. Sorry, I forgot that one, right? We're looking at quarters, we're looking at thirds, we're looking at sixths, we're looking at halves. All right, so these are all special angles that we'll be working with a lot. So here I've got the circle and I have all of the parts labeled in degrees, and we want to talk about the radian measure at each of these parts. And this is the same thing where we're talking about the unit circle. I'm going to say this radius is 1. So I'm really asking you for the arc length, or the arc measure is what I'm looking for. So I'm going to start with what we're going to call the boundary angles. So there's 0, 360, 90, 180, and 270. So 0 is just 0 pi. 180 is pi. 360 is 2 pi. Well, let's look at 90 and 270. Well, if we know from here to here is pi, then this is pi over 2. If we know that here is pi to 2 pi, and that's halfway between them, well, that's got to be 3 pi over 2, right? So you're dealing with 1/2, 1 whole, 3/2, 2, right? Now we're going to split those up even more. So let's see. 45 is going to be pi over 4. Well, that's halfway between 0 and pi over 2. That's halfway between 0 and 1/2. Well, what's halfway between 1/2 and 1? 3. 3/4? 3 pi over 4? 3/4 pi? What about this 225? Well, that's halfway between pi and 3 pi over 2. Halfway between 1 and 1/2. 5/4. Right? 5 pi over 4, that's 1 1/4. What about this 3/15? That's halfway between 3/2 and 2. 7. Ooh, that looks interesting. 7 pi over 4. Why does that look like that? I'll write that in better. That's a 7. Right? So look at this. 0, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. This is just 6/4. 7/4, 8/4. Right? You're splitting it into parts, like cutting a pie. Now let's look at these other ones. So 30 degrees. 30 degrees. So it's not halfway between 0 and 45, right? But you can think 30 degrees. I mean, you can think about this in a few ways. It's a third of 90. Well, what's a third of pi over 2? Well, pi over 6. We'll double that to get the 60. Right? Double that to get the 120. How do you go from pi over 6 to 150? How do you go from 30 to 150? You multiply it by 5. Oh, so that's 5 pi over 6. Right, so now I'm going to do all the 30 increments, kind of. So I'm going to focus now on this 210. Well, what about 30 to 210? You can even kind of see, isn't that 180 degrees? 180 degrees is pi radians. So I want to add pi to that. Right? Like, this has to be 6/6. So this is just going to be 7/6. You're adding pi. You're adding 6 pi over 6. That's all that's happening here. And then let's look at this other 30. Right? So this is going to be pi over 6 less than 2 pi. Or you can think about it's got to be pi more than 5 pi over 6. Well, what does that make this? This is 2 pi is 12 pi over 6. This has to be 11 pi over 6. And let's fill in these last few. So 60 degrees, I mean, there's a few ways you can think about this. It's double 30. It's a third of 180. No matter which way you spin it, you get pi over 3. 120 is going to be double that. Right? You get 2 pi over 3. What about this down here, this 240? We can tell that's half a circle more. So I'm going to be adding, well, what? 3 pi over 3? I'm going to end up with 4 pi over 3. What about over here? Right? I'm going to be 300. I want to add pi to this 2 pi over 3. Right? That's like halfway more around. So if you add 3 pi over 3, you get 5 pi over 3. So what I'm putting up here is the unit circle. And these are values that we're going to be working with a lot. And hopefully you see the value of working with radians, that they're just fractions of the semicircle. They're portions of the circle. So we're so trained to work or think in degrees, and you kind of want to transition or attempt to transition your thinking to be more in terms of radians. We're going to be working with both for the time being, but our goal is to kind of think more in terms of radians. And to be able to do these fairly quickly, right? To think about, well, right now, how long does it take you? And then let yourself know so then you can see growth and you can see improvement as we move through and forward with this. So look for patterns as well. Look for things that you can remember of how you're going to fill in the unit circle. So I'm not going to do too much with this because I think I've said it a little bit, but your boundary angles are the ones that happen on the axes. So that's like 0, 180, 90, and 270. I'm going to highlight some patterns, right? So 0 and 180, there's pi between them. 90 and 270, there's pi between them. The quadrants are important for us to know, like what happens in quadrant 1, quadrant 2, quadrant 3, quadrant 4, because if we know one of the quadrants, we really know them all. Right? Like if you can fill in quadrant 1, you can work with essentially all of them. So 30, 150, 210, 330. Look at the pattern between those. And I just highlighted these as well, so I'm not going to rewrite them all in. But if you want to think about it, 30 degrees was pi over 6. Right? 45 degrees was pi over 4, and 60 degrees was pi over 3. Oh, this was 2 pi over 3. This was 3 pi over 4. What's happening to go from here to here? What are you adding? 80 degrees, right? What happens when you go from here to here? 180 degrees. So you're adding pi. So this is going to be 7 pi over 6. 330, that's almost going to be a whole, but not quite. 11 pi over 6. 150 is almost going to be a full one, but it's going to be 30 degrees less. So it's pi over 6 less than a full circle. So that's going to be 5 pi over, I'm sorry, then a full semicircle. Look at these patterns that we're finding. This is 3 pi over 4. This is going to be 5 pi over 4. This is going to be 7 pi over 4. Right, this is pi over 6. This is 5 pi over 6. 7 pi over 6. 11 pi over 6. Let's see, what else am I missing? What did I forget? Oh, the 240. So 240, that's going to be 30 degrees more than, that's like 60 degrees less, or pi over 3 less than a full circle. What is that, 5 pi over 3? Oh no, it's not, it's 4 pi over 3. Not less than a full circle, less than 3/4 of a circle, sorry. This is 60 degrees less, so this is 5 pi over 3. My fault. And then, sorry, I guess I should fill these in. This is 0 and 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. Right, so all of the ones that you're looking at right here, oh, here's my patterns, are special angles and arcs that we're going to be working with a lot. There is a formula that I'm going to go through, but if it's a special angle, we shouldn't be using the formula, right? Like, we don't want to sit there and use the formula. So I will give you a few where you're going to work on that, but it doesn't have to happen, or it shouldn't be happening on every single problem. So radians, you're going to do pi times the degree divided by 180. The degree units are going to cancel, right? So it's the degree divided by 180 degrees. And then the degree is 180 degrees times the radians divided by pi, because the radian is the fraction of the semicircle. Oh, the fraction of the semicircle. How many degrees out of 180? And again, the units will appear for this one. Radians are unitless. So, write each degree. This is where we're going to check in to make sure that we get this. 150 degrees. So what is the fraction of the semicircle? Well, is this a special angle? Is this an increment of 30, 60, 90, 45? Right? This is 30 degrees less than a semicircle. So that's going to be pi over 6 less than pi. This will be 5 pi over 6. Try to think through it. Not special as that. So here we're going to use the conversion. 7 pi degrees times pi over 180 degrees. So right here, this is what I mean by the units canceling. Those degrees are going to cancel. And I'm going to be left with 7 pi squared. That's fun. Over 180. That's your answer. Weird. 42, not special. This is special. Yay. Not special. Sad, not special. Sad face again. So 42 times pi over 180, right? Because it's the what fraction of the semicircle. Those units cancel. 42 over 180 is 21 over 90, right? So I get 21 pi over 90. Oh no, that simplifies even more, doesn't it? 7 pi over 30. Is that right? Yeah. 300. That's special. Right? So that's going to be 60 degrees less than a full circle, or 30 degrees more than 3 halves of a circle. So I'm going to think about it in terms of it's going to be 60 degrees less than a full circle. So 360 degrees is 2 pi. If it's 60 degrees less, 60 degrees is pi over 3. So I want to get rid of that, right? So I want to say like, oh, it's 6 pi over 3 minus 5 over 3. Oh, that's 5 pi over 3. There's other ways to think about it. I'm just trying to give you a way right now. So that's going to be 5 pi over 3. And if you want to check it, go ahead and use that the calculator and do, well, what is 300 divided by 180? Oh, check that out. It's 5/3. Right? So that formula only used for things that aren't special. So write each radian as a degree. So again, if it's special, don't use the formula. Here's the formula. Not special. Right, so we're going to do 4 times 180 divided by pi. What's 4 times 180? 720? Yeah. So you get 720, and this is degrees, and that's where the degrees comes from. You're multiplying something that's unitless with something that has a unit. 720 over pi degrees. I could divide, but I don't really want to. Pi over 5 fits. That's not special, right? But you're trying to figure, well, this is saying it's one, I mean, you could really think of this as special. This is 1/5 of a semicircle. You want to think about it like that? And you could say, well, 180 divided by 5 will get it to you, but watch what happens when you use the formula. Pi over 5 times 180 over pi. The pi's cancel. And then that's really what you're doing. You're doing what I just said. It's saying, what is 1/5 of 180? 180 divided by 5 is 36. So you end up with 36 degrees. Whoa. 36, not 360. 4 pi over 3, definitely special. This is going to be more than a semicircle. So it's going to be more than pi. I'm sorry, this is going to be more than 180. Sorry, I was thinking in radians. It's going to be a third more. Well, what's a third of a semicircle? Oh, 60 degrees. 60 degrees more than a semicircle. So 180 plus 60, 240. And if you want to use the formula to check me on that, 4/3 of 180 is 240 degrees. Also special. This is 3/4. Think about this. Like this right here, I'm saying you're going from here to like right here. Well, how many degrees is that? 3/4. Right? So it's 45 degrees less than 180. That is 135 degrees. Practice. If you're feeling you understand it, I would just practice it to increase the speed at which you can work through these. So that your speed or your pace of this is not a hindrance as we move forward for a lot of this stuff. And this will come up a ton in pre-calculus next year as well. So throughout this lesson, and maybe a lot of this was reviewed to you, and that's fine, we used what we knew about circles in order to change between radians, a radian measure and an arc length. I'm sorry, the radian measure of an arc length to the degree measure of an angle and vice versa, right? So we went both ways, as well as kind of defined what a radian actually is. So you can feel free to go back and watch any part of this, or I encourage you to use all of the extra practice there as you are working and reviewing and checking your understanding. Thanks, guys.